Welcome back, and let's discuss on a very important point that why we require the Helm. What is the use case which Helm is resolving, and what happen if we are not using the Helm? How the things are working before the Helm. So this is the very important point which will help you to understand how the world is working if they are not using the Helm, and what could be the possible issues scenarios you can face if you are not using the Helm. So let's assume the word without the Helm, but is still on the Kubernetes. So we are already aware that Helm is a application which is used for the application deployment on the Kubernetes only. So Kubernetes is already there, but we are not using the Helm. So how you create the resources on the Kubernetes? How you basically create the multiple deployments on the Kubernetes? If you are not using the Helm, then to create the resources on the Kubernetes, you rely on the Kubernetes YAML files. So you usually create the Kubernetes YAML file. And if there are multiple resources, let's assume there are the web application. Let's assume there are the web application. There are app application. There are DB server. Then you need to create the individual resources for all of these resources. And along with these resources, you need to create the YAML for the secrets. You need to create YAML for the services. You also need to create the YAML for the config map, and there could be the n number of YAMLs you need to create if you are not using the Helm. On the similar pattern, the YAML files you are creating for your workload configuration on the Kubernetes, you need to mention each and everything in that YAML file along with the name, API version, descriptions, the application specification, images. There could be the n number of things you need to specify in these YAML files. And if your application need the multiple services, then many times these YAML files are going to be quite long or quite complex, and any manual intervention may lead to a error. Let's assume now you need to set up a new Kubernetes workload. I mean to say you need to create the another deployment, right? So what you need to do? You need to create the YAML files again for that new workload, because for the previous workload you have the YAML files, and definitely you are going to create the new workload. You need to create the new YAMLs because over there the application name could be different, the port numbers could be different, the host machine port could be different, the load balancer naming convention could be different. So there could be the multiple things which may vary from one workload or one environment to the another environment. And for each environment, whenever you are creating the new full stack environment, you need to create the copy of your YAMLs, you need to update these YAMLs, and you need to use these updated YAMLs for the new workload. So what is the problem of this scenario? The YAML files, whatever the files we are creating, these YAML files are the static files, right? And they don't receive any parameter dynamically. So always we need to copy the YAMLs, create a separate copy or create a separate version of these YAMLs. We need to do the modification, and then we need to apply these on the Kubernetes cluster. That is a manual work, and that require a lot of effort. Plus that is a error prone as well, because human can do the mistake, and due to any single mistake you need to repeat these things again and again. So there could be the iteration while you are deploying your workload. So YAML management, YAML creation, keep the multiple copies of the YAML is a one primary problem if you are not using the Helm and you are deploying the workload on the Kubernetes. Another thing is the consistency. Consistency is the major issue with the handcrafted YAML or the deployment. Consistency means whenever we are basically creating the copy of the YAML, who will guarantee that we have not used the port or we have not used these deployment names in the previous versions, right? And how we will make sure that the YAML which we are copying around environment to environment, they are consistent. One more scenario, let's assume you have deployed the environment. Now somebody simply go to the Kubernetes and he executed some kubectl commands and he modified the environment. Now your environment is modified, your YAML is outdated, but still you are using the same YAMLs. So consistency is the another major problem with the manual YAML management. Another problem is the revision history of your application. Kubernetes does not maintain the revision history of your application. Revision history means, let's assume in 2020 somewhere you deployed your application, the application version was version 1. 2 months later, 3 months later, in the next release you deployed the new version, then you deployed the new version, then you deployed the new version. So this is a release history of your deployment, right? It may possible sometime you need to deploy a few of the component, You don't need to deploy the complete deployment, right? If there are four application which is the part of your deployment, let me explain here. Let's assume this is your deployment and there are four applications, right? These are the four applications: application A, B, C, and D. Whenever you are creating the new version, you are creating the version v2, you are upgrading your application. It may possible you need to only change the application A and application D. You don't want any change in the B and C. Then what you will do in the version v2? In the version v2, you make your changes in the YAML files and you will redeploy all the YAMLs. Kubernetes is not maintaining the version history. YAML itself is not maintaining the version history. In that case, if you want to roll back, how you will roll back? There is no version history available in the Kubernetes and there is no version history available in the YAML. How you will roll back your workload if you want to roll back to the previous version? So version maintenance or maintaining the version is the another problem which Kubernetes or YAMLs are not solving. So in this case, we have the user who is using some router and they have the different deployments, web server, app server, and DB. Once they switch to the version, the fresh version, there is no way to roll back to the previous version. So this is the another issue if you are not using the Helm. So using the Helm, we can solve these problems. And in the coming lecture, we will learn that how Helm solve these problems. So thank you, team. See you next time.